Okay, continuing with the idea of intersecting lines, now we're going to jump into transversals and specific parallel lines and angles that are formed by those. So essential question, how can you prove and use theorems about angles formed by transversals that intersect parallel lines? So we're going to do a little investigation, or we already did this investigation in class already. And so we're going to use those same concepts that we kind of developed through that investigation as we move forward. So a couple of definitions. So as we look at this angle pair, so we're looking for an angle that lie on the same side of the transversal. So that'd be angles 1 and 5. That'd be those angles there. And what we call those angles, those are corresponding angles. And the second one, we're looking at angles 3 and 6 now. So those are those angles there. And so those angles lie on the same side of the transversal and between the intersected lines. And we call those same side. And mostly we say same side, but these are technically same side interior. The next one is looking at angles 3 and 5. So as we look at that, our transversal is T. They're non-adjacent angles that lie on opposite sides of the transversal between the intersected lines. So that kind of gives you a clue. So opposite sides, another way is saying alternate. And then it's between the intersected lines, so that is interior. And then angles. And last, they lie on opposite sides of the transversal and outside the intersected lines. So we're looking at 1 and 7. And so those we call are still alternate because they're on opposite sides of the transversal. But this time they're outside, so we call that exterior. Okay, so a couple definitions with those corresponding angles: same side interior, alternate interior, and alternate exterior. All right, so same side interior postulate states if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So let's work step through this. So we're going to draw two parallel lines and a transversal. It doesn't have to be perfect, but those are pretty close. And then go ahead and label those. Let's go 1, 2, 3, 4, 5, 6, 7, 8. And then we want to identify our same side interior angles. So we would say angle 4 and angle 5. And angle 3 and angle 6 would be our same side. And what does the postulate tell you about these same side interior angle pairs? So it tells us that they are supplementary. So that means that measure of angle 4 plus the measure of angle 5 equals 180. And the same thing, measure of angle 3 plus measure of angle 6 also equals 180. So with that, if we know that measure of angle 4 is 70, we can find the measure of angle 5. Subtract 70 here. And then measure of angle 5 equals 110 degrees. So going here, 3 and 6. Explain how you can find the measure of angle 3 in the diagram if P is parallel to Q and measure of angle 6 equals 61. So that's looking back at the previous one. How can we do that? And then if if M is parallel to N, how many pairs of same side interior angles are shown in the figure? And what are those pairs? So looking at this figure here, what are the same side interior angles? All right, so alternate interior angles theorem states if two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So we want to prove this. So this is a two-column proof like we did in 14.1. So we are given that P is parallel to Q. So our first statement, our reason here is given. So that's that reason there. Now, we're going to use some of these more than once, but this is your list of reasons you're going to use here. So angle 3 and angle 6 are supplementary. So that would be our same side postulate. Okay, since we already proved that, we can now use that in other problems. Then we know that measure of angle 3 plus measure of angle 6 equals 180. And that is definition of supplementary angles. All right, so now that I got you started, I want you to go ahead and see if you can't finish out the rest of that proof. We'll discuss this column interval. You do share out your steps when we come to class. All right, little reflection here. States in the figure, explain why 1, 3, 5, and 7 all have the same measure. So looking down over here, 1, 3, 5, and 7. And then suppose angle 4 is equal to 57 in the figure shown. Describe two different ways to determine angle 6. Okay, again, make sure you have your answers written down. We'll discuss this one when we come into class. All right, corresponding angles theorem states if two parallel lines are cut by a transversal, then the pairs of corresponding angles have the same measure. All right, so this one here is now a paragraph proof. And so similar idea as a two-column proof, but you're just kind of writing it out. We're going to fill in the blanks on this one. So by the given statement, P is parallel to Q. Angle 4 and angle 6 form a pair of alternate interior angles. So using the alternate interior angles theorem, we then know that measure of angle 4 is equal to measure of angle 6. And angle 6 and angle 8 form a pair of vertical angles. So using the vertical angles theorem, we can state that measure of angle 6 is equal to the measure of angle 8. So using the substitution property, of equality in measure of angle 4 equals measure of angle 6, we're going to substitute measure of angle 8 for measure of angle 6. The result is measure of angle 4 equals the measure of angle 8. And our reason, if you don't quite follow that, is here we have measure of angle 4 equals measure of angle 6. And here we have measure of angle 6, which equals the measure of angle 8. Well, take out the measure of angle 6 there. That gives you measure of angle 4 equals measure of angle 8. All right, so reflect So suppose measure of angle 4 equals 36 degrees. Find measure of angle 5. And explain, we'll discuss this one in class. All right, I want to find the angle pair relationship. So in the diagram, roads A and B are parallel. Explain how to find the measure of VTU. All right, so we want to find VTU, which is that one there. So the question is, how do we go about finding that? So we're also given QRP is x plus 40. So now we need to figure out what type of angles we have there. We can start by stating that the measure of angle QRP is equal to the measure of angle TRV, and a reason for that is vertical angles and then we can say that measure of angle TRV is equal to the measure of angle VTU, and that is one of the things we just proved, which was corresponding angles. So then we can state that the measure of QRP is equal to the measure of angle VTU. And that is substitution. And then we know that QRP is x plus 40, and VTU is 2x minus 22. And then now we can go ahead and just solve. So I'm going to add 22. We get x plus 62 equals 2x. Subtract x, and 62 equals x. And we want to measure a VTU, so we know that the measure of VTU is equal to 2x minus 22, so substituting our x value in. So 2 times 62 is 124, minus 22 gives us 102 degrees for the measure of VTU. All right, so another problem here. We have A and B are parallel. We want to explain how to find the measure of WUV. Okay, so WUV. So see if you can work your way through doing that one. And we'll discuss this back in class. All right, so there's a toolkit. We shared this in Google Classroom. I'll go over it a little more in class of what we want to do with this. Elaborate. So how is the same side interior angles postulate different from the other two theorems in this lesson? Alternate interior angles and corresponding angles. So 3 of them, same side interior is different. How? Be ready to answer and justify your answer in class. And then our check-in, if you know that P is parallel to Q and given one angle measure, can you find all the other angle measures? So it's going to be a yes or no, but then the important part is I want you to explain. Okay, so I'm in class they may give you an angle. And another one, I want you to tell me how you can show that those two angles are the same or how they're not. And then last, your assignment.